Welcome to the history of transformers, how and where it all began. Before transformers, before ChatGPT, before modern AI, there was a hidden story about one concept: dimensions. Why does AI use 300 dimensions? Why 512? Why 1024? These numbers are not random. They come from long evolution, from mathematics to information retrieval to neural networks. This presentation traces how dimension transformed from simple coordinate into containers of meaning. In the 1800s, dimension meant something simple. A vector was just a list of numbers. The length of that list was the dimension. 1D, a line; 2D, a plane; 3D, a cube; and number of dimension ND, a feature space. Dimension was geometry. It described degree of freedom. This mathematical language, n-dimension vector space, is what machine learning would later borrow. In 1950s to 70s, the problem was information overload. Scientific papers were exploding in numbers. Humans could not read fast enough. Gerard Salton introduced the vector space model. Documents became vectors. Similarities became geometry. If two vectors are close enough in space, they discuss similar topics. Cosine similarity turned search into math. Dimensions now meant a way to measure meaning. The sparse era, when dimension equaled vocabulary. Then came the bag of words model. If your vocabulary has 50,000 words, every document becomes a 50,000 dimensional vectors. Each dimension represents one word. But most entries are zero. These vectors were huge, sparse, rigid. Synonyms did not match. Cars and automobile lived in completely separate dimensions. Meaning was fragmented. The great compression. The breakthrough was compression. Using single value decomposition, short SVD, we reduced 50,000 dimensions into around 300 latent concepts. We stopped counting words. We started counting hidden structure. Dimension became a design knob, not fixed by vocabulary size, but chosen to capture deeper meaning. Dimensions were handcrafted. In the 1990s, machine learning relied on feature engineering. Dimensions meant number of engineered features. Does the email contain Viagra? Is it all caps? Is the sender unknown? Each feature was manually designed. A 10,000 dimension space meant 10,000 human decisions. Intelligence was handcrafted. The neural turn. Then neural network changed everything. Instead of designing features, we let the network learn the vector. Representation learning emerged. Dimensions became learned parameters. The system automatically discovered how meaning should be encoded. This was the neural turn. The word-to-vector standard. In 2013, word-to-vector made embeddings practical. Words became dense vectors, often 300 dimensions, and meaning became algebra. King minus man plus woman equals queen. 300 dimensions become the industry standard. It was large enough to capture nuance, but small enough to compute efficiently. Dimension now meant width of meaning. Static meaning in the dynamic world, but there was a flaw. Static embeddings assign 1 vectors per word. The word bank has the same vector in riverbank, bank deposit, meaning was frozen. But language is contextual. We needed dimensions that could morph based on conversation. Sequential processing, hidden state, vanishing gradient. Recurrent neural networks process text sequentially. They had memory, a hidden state, but memory was limited. Like a genius with Alzheimer's, smart but forgetting earlier context. By the end of the sentence, vanishing gradient restricted long-range understanding. The bottleneck was memory capacity. Transformers architecture diagram. In 2017, the transformer removed recurrence entirely. Instead of processing sequentially, it looked at everything at once through attention. Even word could directly connect to every other word. No fading memory, no bottleneck. This was a fundamental shift. Trophy example Q, K, V scale dot product attention. Attention works like highlighter. For each word, the model asks, "Do you matter to me?" Using queries, keys, and values. It computes scale dot product attention. In the sentence, the trophy doesn't fit in the suitcase because it is too big. Attention helps resolve what it refers to. Dimensions now hold contextual meaning. 512 splits in 8 heads of 64. Transformers turn dimensions into a control panel. If the model dimension is 512, it splits into 8 heads of 64 each. Each head captures different relationship, syntax, semantics, long-range dependencies. Dimension became parallel processing with not just size but structure. Maths, IR, LSI, Word2Vec, RNN, transformers. Look at this progression. Dimension evolved from math coordinate to document indexing, to latent concepts, to word embeddings, to contextual representation, to transformer models. The number grew 300, 512, 1024, but what really evolved was meaning capacity. The width of understanding. These numbers are not magic. 300, 512, 1024. They represent the complexity of the word the model is trying to map. Transformers gave AI a memory that doesn't fade. Dimensions learn to carry the weight of context, from static lists of zeros to dimension spaces of understanding. That is the evolution of dimension. Thank you.